Okay, so there we go. So good afternoon again, everyone. Last week, bago pa magkaroon ng academic break, we discussed about the permutation and on how to answer and get the permutation of the given example, such as we have the formula of the permutation of a number is equal to n factorial over n minus r factorial, in which n is the objects taken, and r is the time denoted. Okay? So last time also, we have this example last week. Bigyan ko na rin kayo ng briefing or ng ulit ng paalala ko na rin ulit sa inyo kung paano ba natin to discuss nung nakaraan. So we have here example number 2, write the formula of the PNR that will represent as solution to the given situation and determine the number of permutation. So, in letter A, how many arrangement are if we are talking about combination and permutation, combination, even the given, the order is not that big deal. Parang kahit hindi siya maayos yung order niya, combination yon. Pero, pag sa permutation, yung combination niya dapat maayos or may tamang arrangement siya. So, in this example, can be using letter A, B, C, and D. So, this would be your N or your object, the A, B, C, and D. And then, it is taken 4 at a time. So, your time or your time denoted is 4. So, therefore, if you have here as your formula, okay, so we got N is equal to 4 factorial and R is equal to 4 because we have only 4 objects. 4 as our object and another 4 for our time. For at a time. Nakalagay po dito, for at a time. Okay? So, this is our time. For at a time. So, continually, so habang sinusunod natin yung formula, we will get n factorial over n minus r factorial. So we have here 4 factorial, and 4 factorial is equal to 4 times 3 times 2 times 1. Remember that if we are talking about factorial, so ang gagawin lang natin ay i-multiply natin from that number hanggang makarating ka ng 1. So for example, we have here 12 factorial. 12 factorial is equal to 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 and 2 and 1. So as simply as that. When you hear the word factorial, it is from the number itself going to 1 and multiply it all together. But then, hindi naman mahigpit si ma'am sa paggamit ng calculator. Of course, it is very um, long, masyadong mahaba yung method na yan. We can use calculator. So, if you have calculator with you, and we are talking about 11 factorial or 12 factorial, and just type or key in or key in the factorial sign or symbol like that. Ayan. So, and then, have it the equal sign. So, ito yung sagot niya. So, this is equal to 12 factorial. So, pag minano-mano natin yung 12 times 11 times 10 times 9 times blah 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 hanggang maging 1, so this would be the answer. So, syempre, hindi ko na mapapaabutin kayo na mag-multiply ng ganyang kalaki, di ba? So, pwede kayong gumamit ng calculator with that. And then, so we have here 4 factorial, going back. So we have here 4 factorial over 4 minus 4, because we have n minus r factorial. So we have here 2, 4 minus 4 is 0. So 0 factorial is always equal to 1. So I'm gonna show you. So 0 factorial is equal to 1. Okay? And then, so we have here 24 over 0 factorial or 1. We have here 24 arrangements. Naalala na po ba? Pakikiin nga po. Taray naman ni Hans. Okay, pakikiin nga po kung naaalala na yung diniscuss natin nung nakaraang linggo. So we can now proceed on our week 2, week 1 and 2 presentation. Hello? Naalala na po. Okay, good. How about the others? Also, another example, just like that again. For example, number 2, write the formula in permutation of n and r that will represent a solution in a given situation and determine the number of permutation. So we have here 6 different books as our objects and distributed to 2 students. So we have here 6 and 2. Having the formula, we have here 6 factorial over 6 minus 2 factorial. We have here 720 over 4 factorial. 4 factorial is 24. 720 over 24 is 30 ways. So as well as with this, determine if it is a permutation of or not. So again, it is permutation if it requires order arrangement. If it requires order arrangement, pag merong pagkakasunod-sunod na eksakto, permutation yon. But if not, kung kahit labo-labo sila, okay lang, combination lang yon, or this is not a permutation. So for our example, letter A, B, C, and D, the advisor arranges surnames of students alphabetically. So what would be? Alphabetical daw. It is a permutation or not?
Permutation po.
Okay, good. So it is a permutation kasi merong arrangement or merong pagkakasunod-sunod. How about in this letter? The teacher is selecting 5 classmates to represent the class. Permutation or not?
Hindi po, ma'am.
Hindi po. Very good. Why? Kasi nag-select lang naman ng 5 classmates. Hindi naman sinabi na the top 5 or the most um, tallest of all your classmates, wala namang ganon, di ba? So, kasi wala siyang arrangement, wala siyang tamang pagkakasunod-sunod, or hindi siya ordered is not important, therefore, it is not a permutation. How about letter C? Jairo Ang, it's nice to see you here. Oh, letter C. Jairo Ang. Open your mic. Can you open your mic? Nice to meet you. Sabi ko, nice to see you. Game, ano? Go ahead. Look again. Look at the letter C. Yes, it is a permutation. So ba? Very good. Because we are looking for the top 50. Okay, good. How about letter D? Rodel sent the pin in a combination lock. Permutation or not? Piel. Permutation, good. Kasi hindi naman pwedeng mali yung pin or wala siyang pagkakasunod-sunod. So, dito naman, letter E, you are choosing 3 different fruits from the box. Permutation or not, Angel? De Guzman? Not. Okay, exactly. Kasi, wala namang pagkakasunod-sunod. Kahit anong klaseng fruits yung makuha mo, it doesn't matter. So as well as in this case, diniscuss din natin yung listing method na kung saan nilist natin mano-mano, nakakuha tayo ng 24 possible arrangements. Ito yan, mano-mano yan. Sabi dito, pag sunod-sunod rin daw yung ABC, ilan daw yung ABCD, ilan yung makukuha combination. Pag tatlo lang sila at a time. So nakakuha tayo ng ABC, ABD, ACD, blah blah blah. Ang lahat na yan ay 24 combinations. And we can conclude that if we're gonna use the formula for the permutation, we can also get 24. Therefore, we can use either of the two. Kung saan ka mas nadadalian. Of course, syempre, for me or for others, mas madali talagang gumamit na lang um, ng permutation formula. But if you want to double check it, gusto mong i-double check, you can do listing. Okay? Next. For a while, ha? Okay. And then, no more, no less. So, dun pala tayo nag-end up last week. So now, we're gonna discuss about the week 2 as well as the continuation. Week 1 as well as the continuation of the week 2. Paki-beep or paki-key in ako if our um, presentation ay may sounds po or wala. May sounds po ba?
Meron po, ma'am.
Okay, good. So, it is a 28-minute video. So, yes, kakainin na nito yung 30 minutes natin, exactly. And then, after that, we will conclude and we will sum it up. And then, ipapakita ni ma'am sa inyo yung mga sasagutan nyo on your module and last. Please, pwede kayong mag-jot down, pwede kayong mag-sulat, pwede kayong sumabay sa mga examples and givens na mapapanood nyo dito. And please, maglaan kayo ng time while watching this. Kasi kung tutuusin, pwede ko namang i-cut na yung stream natin at i-forward ko na lang sa inyo yung link, right? But then, hindi ko gagawin kasi para ma-supervise ko na pinapanood nyo talaga yung video. Kasi pag shinare yan sa GC or whatsoever, alam ko naman, hindi naman talaga rin lahat pinapanood. Pero para ma-sure natin na talagang nandito tayo sa stream and we're watching it, we're gonna have some samples, activities, and conclusion, generalization after this stream. Are you all ready? Press 1 if yes. Okay, good.
Hello, Acute Angels. This is Teacher Anna, and welcome to another matinee episode. Today, we will talk about permutation. Are you ready? Well, at the end of this lesson, you are expected to illustrate the permutation of objects and solves problems involving permutations.
For a while lang.
You are expected to we will talk about permutation. Are you ready? Well, at the end of this lesson, you are expected to illustrate the permutation of objects and is a collection or a combination of objects from a set where the order or the arrangement of chosen objects does matter. In other words, a permutation
Delay
is
ba
an
yung sounds
ordered
niya or hindi
combination.
naman?
But why an ordered combination? Well, in English, we use the word combination loosely, without thinking if the order of things is important. For example, my fruit salad is a combination of
Hindi
apples,
naman po, ma'am.
grapes, and bananas. And we also have the combination to the state is 4, 7. If we dig deeper, in the sentence, my fruit salad is a combination of apples, grapes, and bananas, we don't care what order the fruits are in. They could also be bananas, grapes, and apples, or grapes, apples, and bananas. It's the same fruit salad. Well, for this sentence, the combination to the same is 4, 7, 2. Now, we don't care about the order. 724 won't work or will 247. It has to be exactly 472. So in mathematics, we use more precise language. When the order doesn't matter, it is a combination. But when the order does matter, it is a permutation. Now, let's see some examples. How many ways can we arrange three students in a line for a picture? Let's say those three students are Anna, Ella, and Ross. Using an illustration, the first arrangement could be like this: Anna, Ella, and Ross. For the next one, we have Anna, Ross, and Ella. We also have Ella, Anna, and Ross. Also, we have Ella, Ross, and Anna. The next one is Ross, Ella, and Anna. And lastly, we have Ross, Anna, and Ella. By counting, we can conclude that there are 6 ways to arrange three students in a line for a picture. But what if instead of three students, we have 7? How many ways can we arrange 7 students in a line for a picture? Are we going to do the same? Let's say those students are represented by A, B, C, D, E, F, G. Here are the possible arrangement: A, B, C, D, E, F, G. The next one is A, B, C, D, E, G, F. The third arrangement could be A, B, C, D, G, E, F. The fourth one could be A, B, C, D, G, F, E. And the list goes on and on, which is quite impossible for us to know in a short period of time if how many arrangement can be made to them because we are using the listing method. But wait, we have another method to solve for it. In general, the number of distinct permutations of n objects is n factorial, or in simple, is n with an exclamation point. Since it's only asking about the number of ways, not the list, we can use this formula, n factorial. But what is factorial? Factorial means to multiply a series of descending natural numbers, which means we are going to stop multiplying if we reach 1. For example, 4 is equal to 2. And for 1 factorial, we have 1, since it is the last number. But we have a special case, 0 factorial. 0 factorial is equal to 1, just as 1 is equal to 1. Since it is all about arrangement, if we have nothing, that's already an arrangement. So we consider it as 1. Again, 0 factorial is equal to 1. So, going back to the question a while back, how many ways can we arrange 7 students in a line for a picture? We can now identify the number of ways using the formula n factorial. N is equal to the number of objects, which in the given problem is equal to 7. And substituting into the given formula n factorial, we have 7 factorial. And 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial now is equal to 5040. Therefore, there are 5040 ways to arrange 7 students in a line for a picture. Now, let's try to answer the first problem we solved earlier. How many ways can we arrange 3 students in a line for a picture? Using illustrations and listing method, we determined that we have 6 ways. But let us see if it is the same if we use the n factorial. N in the given problem is equal to 3, which is from the 3 students. So we have 3 factorial. Now, 3 factorial means 3 multiplied to 2 multiplied to 1. And that is equal to 6. Therefore, there are 6 ways to arrange 3 students in a line for a picture. So we produce the same answer. It's now up to us which method are we going to use. Is it the listing method or the use of a formula? Because at the end, we will end up on the same answer. Let us deepen our understanding about permutation. Aside from the fact that permutation is a collection or a combination of objects from a set where the order or the arrangement of the chosen objects does matter. Permutation can be described also as n distinct objects taken r at a time, where n refers to the number of objects from which the permutation is formed, and r refers to the number of objects used to form the permutation. In symbol, we use the following notations. In short, permutation is not all about the arrangement of all the objects in a given problem. There are times we need to arrange a certain objects, but we only have limited slots. Like for instance, arranging 5 photos, but we only have 3 picture frame. And for that instances, we use this the permutation formula, which is also known as the formula for permutation of n objects taken r at a time. The permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial, where r is less than or equal to the value of n, and p with the quantity n and r is the number of permutations, while n is the number of objects in the set, and r is the number of choosing objects from the set. For example, in how many ways can we arrange 2 letters from the word plant? List all the possibilities. In here, we have 2 options. Either we use the permutation permutation formula, then list all the possibilities after. Or we just list them, then count it after. But in my own opinion, I prefer to solve it first using the formula so that when listing, I already know how many arrangements should I write. So let us identify the given first. N is the number of objects, which in this case is the number of letters in the word man, and that is equal to 4, while R is the choosing objects in the set. Out of the four-letter word, we only need to choose two letters. Therefore, we have 2 as the value of R. Now, we will use the permutation formula. The number of permutation is equal to n factorial over the quantity n minus r factorial. We are now ready to substitute the value of n and r to the given formula. We have permutation of 4 objects taken 2 at a time is equal to 4 factorial over 4 minus 2 factorial. 4 minus 2 is equal to 2 factorial. And 4 factorial means 4 times 3 times 2 times 1, while 2 factorial is equal to 2 times 1. Here, since we have like terms, we can eliminate them. We cancel out 2 times 1. And the remaining terms that we have now is 4 times 3. And 4 times 3 is equal to 12. Therefore, there are 12 ways to arrange two letters from the word plant. And those are ME, MT, MH, AM, AT, AH, TM, TA, TH, HM, HA, and HE. Let's have another example. How many ways can 4 books be arranged on a shelf if they can be selected from 9 books? First, let's identify the value of n and r. N is the total number of objects, and that is 9 because we have 9 books. R is the choosing objects, which in the given problem is 4 books. R is equal to 4. And again, we are going to use the permutation formula. Substituting the value of n and r to the formula, we have the permutation of 9 objects taken 4 at a time is equal to 9 factorial over 9 minus 4 factorial. 9 minus 4 is equal to 5. 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. While 5 factorial means 5 times 4 times 3 times 2 times 1. And since we have like terms, we can eliminate them. We cancel out 5 times 4 times 3 times 2 times 1. And the remaining terms that we have now are 9 times 8 times 7 times 6. And 9 times 8 times 7 times 6 is equal to 3024. Therefore, there are 3024 ways to arrange 4 books in a shelf, which are selected from 9 books. Aside from the permutation of n objects taken r at a time, we also have special permutations. The first one is the permutation with repetition. If there are n possibilities for the first choice, then there are n possibilities for the second choice and so on, multiplying each time. And we use this formula. P is equal to n times n times n times n, and so on and so forth. or in short, we have p, which is equal to n raised to r. Like in the password, if we are going to create four-digit password wherein repetitions allowed, in the first digit we have 10 choices, and that includes 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Same with the seventh digit, third digit, and fourth digit. So if we represent it, we have 10 times 10 times 10 times 10. Or in short, we have 10 raised to. Let's have an example. If repetition is allowed, how many three-digit number can be formed using 5, 6, 7, 8, and 9? In the problem, the given value of n is 5 because we have 5 numbers which includes 5, 6, 7, 8, and 9. And the value of r is 3 because we are going to form a three-digit number. Following the formula p is equal to n raised to r, we have p which is equal to 5 raised to 3. And 5 raised to 3 is equal to 5 times 5 times 5, which is equal to 125. Therefore, there are 125 three-digit numbers which can be formed using the numbers 5, 6, 7, 8, and 9. Next is the distinguishable permutation. Distinguishable permutations from the name itself are permutations or arrangements that can be distinguished from one another. Consider all the permutations of the letters in the word but. Since there are three letters, there should be 3 factorial, which is equal to 6 different permutations. And those permutations are BOB, BBO, OPP, BB, BBO, and while there are 6 permutations, some of them are indistinguishable from each other. If you look at the permutations that are distinguishable, you only have 3, and those are BOB, OPP, and now, to find the number of distinguishable permutations, take the total number of letters factorial divided by the frequency of each letter factorial. In representation, we have n factorial over k sub 1 factorial, k sub 2 factorial, k sub 3 factorial, and so on and so forth until we reach k sub p factorial, wherein k sub 1 plus k sub 2 plus k sub 3 up to k sub p is equal to. Let's have some examples. How many seven-digit number can be formed from 3, 3, 5, 5, 5, 7, 7? In the given problem, the value of n is 7. And as you notice, number 3 appears twice, and number 5 appears thrice, while number 7 appears twice. And we're going to apply this formula. In the given, 2 is the case of 1, 3 is the case of 2, while 2 is the value of k sub 3. Substituting these values now to the formula, we have 7 factorial over 2 factorial multiplied to 3 factorial multiplied to 2 factorial. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial means 2 times 1. 3 factorial means 3 times 2 times 1. And again, 2 factorial means 2 times 1. since we have similar terms, we can eliminate them. We cancel out 3 times 2 times 1. And the remaining terms that we have now are 7 times 6 times 5 times 4 over 2 times 1, which is 2, and 2 times 1, which is 2. 7 times 6 times 5 times 4 is equal to 840, while 2 times 2 is equal to 4. We now have 840 divided by 4. 840 divided by 4 is equal to 210. Therefore, there are 210 seven-digit numbers that can be formed using the digits 3, 3, 5, 5, 5, 7, 7. In our next example, we need to find the number of permutations of the letters of the word Arab. In the given problem, the value of n is 4 because of the letters of the word Arab. Letter A, R, A, and L. And since we have some objects that appear twice, it is still under the distinguishable permutation. Case of 1, which represents letter A, is equal to 2 because letter A appeared twice. Case of 2, which represents letter R, is equal to 1. And case of 3, which represents letter L, is equal to 1. And again, following the distinguishable formula, we have 4 factorial over 2 factorial times 1 factorial times 1 factorial. 4 factorial means 4 times 3 times 2 times 1. And 2 factorial means 2 times 1. 1 factorial is equal to 1. And again, 1 factorial is equal to 1. As we can see, we have similar terms which we can eliminate. We cancel out 2 times 1. The remaining terms that we have now is 4 times 3 over 1 multiplied to 1. 4 times 3 is 12, while 1 times 1 is equal to 1. We now have 12 over 1, which is equal to 12. Therefore, there are 12 distinguishable permutations of the letters from the word Arab. But additional information, note that it is okay not to include the object who only occur once in the formula, because we will still come up with the same answer. 4 factorial over 2 factorial is still equal to. And for our last type of permutation, we have circular permutation. What is circular permutations? Circular permutations from the name itself are permutations or arrangements that are in circular form. And we have 2 types of circular permutation. Number 1, if n objects are to be arranged around a circle, the number of permutation of n different things is the quantity n minus 1 factorial. And for number 2, the number of permutation of n different things around a curve and the like is the quantity n minus 1 factorial all over 2. In short, number 1 is all about circular objects which cannot be turned or flipped, like a circular table or a maypole. While the second one is all about a circular objects which can be turned or flipped, like a keyring, bracelet, and necklace. Let's look at this example. In how many ways can 4 people be seated at a round table? The value of n is 4, and the formula that we are going to use is the first one, because it involves an object which cannot be turned or flipped. The quantity n minus 1 factorial. Substituting the value of n, we have 4 minus 1 factorial. 4 minus 1 is equal to 3. Therefore, we have 3 factorial. And 3 factorial is 3 times 2 times 1, which is equal to 6. Therefore, there are 6 ways for 4 people to be seated at a round table. So if we illustrate it, let's say those 4 people were represented as A, B, C, and D, and A will serve as the marking point or starting point. This will be the possible arrangement. And for the last example, in how many ways can 6 keys be arranged in a key ring? The value of n is equal to 6. And since it talks about a key ring, the formula that we are going to use is the second one because it involves an object that can be turned or flipped. The quantity n minus 1 factorial all over 2. Now, substituting the value of n to the formula, we have 6 minus 1 factorial all over 2. 6 minus 1 is 5. And now we have 5 factorial, which means 5 times 4 times 3 times 2 times 1, and which is equal to 120. We now have 120 over 2. 120 over 2 is equal to 60. Therefore, there are 60 ways of arranging 6 keys in a cube. That's all you need to know about permutation. Just remember that a permutation is an ordered combination. Angels, you did great in watching and listening. I hope you are now confident to answer activities related to it. Again, this is Teacher Anna, and see you on another monthly episode.
Okay. So, since we're done with the presentation, may sounds ba ako? By the way, do I have sounds?
Meron po, ma'am.
Okay. So, since we're done with the presentation, I will just ask something. Kung ano yung pinaka natandaan nyo doon sa... sorry, meron pa. Kung ano yung natandaan nyo sa 30 minutes presentation na yun, ano yung pinaka nagtunga po, ano ba? Nag-ano sa utak mo, natandaan mo sa utak mo. Hans. And we will
Ma'am,
sum it up later naman. Huwag kayong
ma'am yung,
mag-alala kung nabasa ko kung medyo nalilito.
ma'am yung tatlong special permutation po.
Such as,
Permutation with repetition,
okay?
distinguishable permutation, and circular permutation.
Okay. How about you, Januel Mala? Circular. How about Angel? Tapos yung keyring. Factorial po, multiply as the rest of descending natural numbers. Okay. How about Yel?
Yung 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 distinguishable permutation po.
Okay, so I'm still presenting naman yung screen na naka-present pa ako. Okay.
Opo.
So on your week 2 module or last, so ito yung sasagutan nyo. So yung discussion na-discuss na kanina, pero bibigyan ko pa rin kayo ng hint kung paano nyo mas madaling maiintindihan tong mga sasagutan nyo kasi konti lang naman yon. Meron lang kayo na-chat ko na sa inyong group chat. Ang sasagutan lang nasa na? Sa week 1, okay na? Tapos na tayo dyan. Sa week 2, ang sasagutan lang ay yung let us remember 1 to 3. Ayan. Ano ba? Bakit nawawala? Ayan. Let us remember 1 to 3. Ito yun. What is permutation? What are the types of permutation? And give one example for each permutation. Ma'am, anong example yung bibigay namin? Magbibigay lang kayo ng sample problem with answer of each permutation. So, kahit mag-search kayo or mag-research or whatsoever, pwede. Okay? And then, we have here the evaluation, such as 1, 3, and 1, 4, and 5. Ayan. Ito lang naman. Ay, dapat pala 2 yun. 2, 4, and 5. Sorry. 2, 4, and 5 pala to. Using ko na lang mamaya. Ang sasagutan nyo dito, 2, 4, and 5. So, paano nyo ba yan masasagutan ng madali? Or paano ba natin masasum up yung diniscuss ng um, ng nag ng presentation kanina. So, dito sa Let Us Remember, alam niyo na yan, yan na yung nasa topic 1 natin, nasa quiz 1 natin, module 1 natin. So, in this module, merong ang binigay na given dito is yung repetition is allowed, such as ang ginamit natin, yung discussion sa week 1. Okay? And if the repetitions allowed, ibig sabihin, permutation with identical objects yun. So, merong magkapareha sa kanila. So, bigay ko sa inyo example kanina, such as, ang question, how many permutation you will come up with the word aral? Gaano daw ba kadami yung combinations or arrangements na magagawa natin sa aral if we have distinguished object. Or dito sa given nyo, meron kayong, ang given dito ay vase. Ayan, ito muna, explain ko muna, paliwanag ko muna to, saka tayo magbigay ng actual example. So for example, number 1, suppose you have 2 vases of the same kind. So ito daw yun. And 3 candle stands of the same kind. So ito daw yun. In how many ways can you arrange these items in line in the table? So we can rename as your n sub 1 the 2 vases and n sub 3 your 3 vases. And how many objects do you have? You have 5 objects. So using the formula, since we have identical objects, we have n factorial, ito, over n sub 1 factorial times n sub 2 factorial up to how many objects factorial. So we have here n factorial such as 5 kasi 5 objects yan. And then 2 factorial times 3 factorial. So we have here 5 times 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1. And 3 factorial is 3 times 2 times 1. Doon sa cancellation na sinasabi kanina, kung doon kayo nalilito, pag merong same object sa taas at meron ding same object sa baba, you can cancel it out para maikli na lang yung sinosolve mo. So for this example, you have 5, 4, 3, 2, 1 and 2, 1, 3, 2, 1. So since meron sa taas na 3, 2, 1, meron sa baba na 3, 2, 1, if we divide it by itself, it is 1, right? So since 1 lang naman siya, you can cancel it out na lang para yung natitira na lang yung i-solve mo. So ano yung natira? You have 5 times 4 is 20 and 2 times 1 is 2. So, yan na yung naka-lowest term na siya. So, you have 20 over 10 at 2 is equal to 10. So, yan yung may repetition. Sa may distinguish, yung katulad ng sample nun, yung mga diniscuss natin nung nasa week 1. So, another example, ayan. So, in the word aral, how many combinations we can come up with this one? So, we have distinct object. Ano yun? We have 2 letter A. So therefore, how many objects do you have? Your n is equal to 4. And your k Okay? And your K is 2. Okay? And then, after that, balik tayo dun sa ano nyo. Ayan. So, since you have dito, katulad sa nabanggit ko kanina, dito kasi dalawa yung object, kaya you will multiply it by itself, by the other objects. Eh, how about this one? Ilang object ba yung meron? Ang meron lang ay dalawa lang naman yung may magkapareha. So, yun lang naman yung letter A. So, therefore, you will have 4 times 3 times 2, okay? Ay, undo. Times 1 over 2 times 1. So, pwedeng i-cancel out natin to 2 and 1. And then, your answer will be 12. Nakuha ba yon?
Noted po, ma'am.
Nakuha ba yon?
Yes po.
So, as easy as that lang. Ganun lang naman siya kadali. So, let's tignan natin kung tama ba. Para ma-double check lang natin. Kasi yun lang naman yung pinaka-mabilis at pinaka-madali niyang explanation. There.
5, 5, 7.
Ayan.
Because of the letters of the word Ara. Letter A, R, A, and L.
Okay.
And since we have some objects that appear twice, it is still under the distinguishable permutation. Case of 1, which represents letter A, is equal to 2 because letter A appeared
Ayan.
twice.
So, kung gaano kadami times siyang nag... Okay.
And case of 3, which represents letter L, is equal to.
Okay. So, kung mapapansin nyo dito, sinama pa niya yung R and L, which is equal lang naman sa 1. So, if you will multiply it by itself, 1 pa rin naman yon, right? Okay. So, dito, medyo mahaba pa pala yung ginawa niya. So, pinakita ko naman na sa inyo yung short. Pag 1 lang naman or isang beses lang naman siya, kahit hindi nyo na siya isulat, kasi 1, yung any number, multiply mo sa 1, anong magiging sagot niya? Yung number itself pa rin naman eh, di ba? Okay?
We now have 12 over.
So, therefore, the distinguishable permutation of the letters from the word aral is 12. Okay. How about on our next example? So, we have here the word Mekawayan. Okay. So, let's try it out. So, we have here Mekawayan. Okay. So, in Mekawayan, how many letters were in meron siyang kamuka? So, we have here, sige, ano muna natin, evaluate muna natin. Yung A, meron siyang tatlo.
Tatlo.
Okay, good. What else? What letter
Y
pa?
po.
Y.
Y.
Okay, good. Meron siyang, how many?
Dalawa.
Dalawa. Okay, so paano natin yan sasagutan? Paano natin makukuha yung distinguishable permutation niya? So you have your M, E, Y, C, ilan yan? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So, your permutation, na ba? Ayan. Your total number of letters is 10. And your n sub 1 is, for letter Y is 2. And your n sub 2 for letter A is 3. So, therefore, we have here our n as 10. And our n sub 1 is, pwede natin itong gamitin as 3. And our n sub 2 is 2. Okay, got it? And then, the formula is multiply. N over, ano, tama ba? Yan, dito na lang. Permutation of that number is equal to N over N factorial over N sub 1 times N sub 2 times N sub 3 or kahit gano'n pa siya kadami dyan. And it's factorial. So we have here our N is equal to 10. Okay? And our 3 and 10 factorial. So we have here 3 factorial and 2 factorial. Okay, nakakuha po yun? Nakakasunod? Yes or no? Dito kasi, wala kasi kayong mga mic eh. Okay, good. And then, we have here, i-direct na calcu ko na. Alam niyo naman na yan. 10 times 9 times 8 times 7 times 6 times, okay. I-direct na natin sa calculator. So, we have here 10 factorial is equal to, ay, pwede pala tayo pwede pala tayo mag-eliminate para hindi na ganun kalaki. Sige. 10 times 9 times 8 para makita nyo pala yung elimination. Times 6 times 5 times 4 times 3 times 2 times 1. Okay, over 3 times 2 times 1 times 2 factorial 2 times 1. Okay. So, we have here 3, 2, 1. So, pwede natin itong i-cancel. Itong 3, 2, 1 na to. Cancel out na natin to. Ayan. So, ang matitira na lang, 10 times 8 times 7 times 6 times 4 over 2 times 1. Tingnan natin yung sagot. Ayan. So, we have 604,800. So, we have here 604,800 over 2 equals 302,400. 302,400 combinations yan, permutations. But if you will use calculator, we have here, dito, so we have here 3 to, tingnan natin kung magiging parehas yung sagot. 328,800. And then yung isa ay divide, ano yun? 3 permutation times 2 permutation. 3 permutation times 3, ay times 2. Times 2 permutation over equals, you will come up with the same answer, 3,000, 302,000, and 302,400. Ayan. So, parehas ba sila ng naging sagot sa ating jump board? Yes. Therefore, you can, pag nangingin ng solution, of course, magsusulat kayo ng solution. Pag hindi nangingin ng solution, kung multiple choice or whatsoever siya, hindi naman na kailangan ng solution, hindi na po kailangan magsulat ng solution. Tinuro ko na po sa inyo kung paano po gumamit ng calculator, rekta, kahit nasa given ka pa lang. Okay? And therefore, what else? Tingnan natin kung ano po mga hindi natin nakapap dito. So, ayan, sa circular permutation, very easy. The formula is n factorial over n or n minus 1 factorial. So, for our example, the event coordinator has to arrange a 4 guests around a circular table. So, pag circular permutation, included dito yung circular, any object that is circular. Kadalasan naman, puro round table lang naman yung ginagamit dyan sa circular table, as a circular permutation. So, you have 4 factorial. So, since 4 guests yung meron ka, over n is 4. Or, 4 minus 1 factorial. You have 4 minus 1 is equal to 3 factorial. You have 3 times 2 times 1. You have 6 circular permutation for the guest. Question with our topic and lesson for this afternoon. Kaya na kayang magsagot? Ibahin ko lang yung mga message ko sa inyo. Dapat number 1 yun, hindi po yung number 2. Ay, dapat number 2 yun, hindi po number 1. Yung i-resend ko na lang ulit. May tanong pa po ba? So we can end this stream if you don't have question anymore. Okay, so let me just cut this online streaming. And we'll have our Q&A after I edit out.